Okay. Um, Now number 5, I'm going to have to, video number 5 I'll have to redo. That didn't turn out all that great. And one thing I got hung up on was closures. Other than that, I was doing fairly well with it. A couple of the experiments I didn't do, so we'll go back and do video number 5, which is what. And by the way, we're in the Swift Tour, and we've opened it up in a Xcode playground, which I'm thinking is a really good learning environment for people just to learn how to code. And you can see, yeah, so the one that I missed was enumerations and structures. I'll have to do that over again if I get to it. So I'm just going to continue on. We're in protocols and extensions. Use protocol to declare a protocol. Okay. Looks familiar, doesn't it? Within the brackets, of course, simple description or variable, which is going to be a string. And then they do it like this, get mutating function adjust. So not really sure what that all means, so let's see if we can gain some understanding. Classes, enumerations, and structs can all adopt protocols. All right. Here's an example of a class, and example protocol. It's a variable string, a very simple class. Here's another property, int. We're assigning it a number. Function adjust, a simple description, and we're in this case, this would be concatenation. We're concatenating two strings, and so this is just describing the class. And now down here we're going to call it. We're calling simple class and assigning that to the variable a adjust. So here's a function adjust. So at first, let's see. A adjust, let a description equal a simple description. A dot simple description. Well, simple description, that's up here. So that's where we, a simple description would be a very simple class. And let a description is just a constant that we're declaring. And so let's see what we have over here. Now that is a little bit weird. I have to stop and think about that, because to me the simple description is just the very simple class, this above here. But I suppose since we called adjust, we adjusted our class, and we added or concatenated this now 100% adjusted. So it's adjusted before we do this, which is calling the simple description. So that's the reason why we get it with the now 100% adjusted. So now I'm gonna verify what I just said. Okay, by commenting out the adjustment, and now it just says a very simple class. So that's kind of slick. It's kind of cool. Not sure, where you would use that, or even why, but that'll come clear later on, I suppose, especially when we get into building an app, that kind of thing. So, okay. So let's continue. Now here's a struct, simple structure, an example protocol. Huh. That's interesting. Example protocol. String get. Now you see that's the first thing we did up here is we created this protocol. And now we can use or adopt the protocol when we create a class. String get. And how did that help us? Well, we were able to get our simple description. I thought you could do that anyway, though. So let's continue. So here's a struct. Instead of a class, we're going to do a struct. And we're going to create a variable, and there's our simple description again. Here's another function, adjust. This time we use mutating, so I'm not sure. Let's see if we can figure out what that is. Mutating function, adjust. And then same way as before, adjusted. Why did we have to use the mutating here, but not here? I don't know. So now here we're going to create a variable b. We're going to call simple structure, which would be right here. Then we're going to adjust it like we did before. And then we're going to do the same thing. Simple description. Okay? B, simple description. And we get, so it's basically this same or similar thing, really. Now, I was kind of trying to figure out why we had to use mutating here and not here. Well, one clue for me would be that the difference between these two things is this is a class and this is a structure. That much I do know. So, and I think for now we'll just leave it at that. Everything else seems to be the same in terms of how it's written. See, with the brackets the way they are, the brackets the way they are. Here's your function adjust, and here's ours. Everything looks similar or almost the same, except for this mutating thing. Huh, isn't that interesting? Write an enumeration that conforms to this protocol. I'm not, that conforms to that protocol. I'm not excited about that somehow. I think I'll pass on that for the moment. Okay, let's continue. Notice the use of mutating keyword in the declaration of simple structure. So now I'm going to get my answer maybe. To mark a method that modifies the structure. The definition of simple class doesn't need any of its methods marked as mutating because methods on a class can always modify the class. Use extensions. Use extension to add functionality to an existing type, such as new methods and computed properties. You can use an extension to add protocol conformance to a type that is declared elsewhere, or even to a type that you imported from a library or framework. So now they're going to give us an example. An extension int example protocol. var simple description string, return the number self, and then mutating function adjust self plus 42. Print 7.simple description, the number 7. Yeah. What happened? Now, if I call adjust, let's see how that would work. How about self.adjust, because we didn't, would that work? No, that didn't work, did it? And so, let's use an example. RC equals simple description. Yeah, that's not going to work. Yeah, I don't know. Leave that alone for the moment. Write an extension for the double type that adds an absolute property. Let's back up for a minute. Notice the mutating function of the keyword is simple. Okay, so let's drop down here. Use extension to add functionality to an existing type. Oh, okay. Now, a type is like integer, double, float, string. So our example here, our existing type is int. Oh, and we're adding this extension to where here that allows us for an integer to have a method simple description that returns a string. That's kind of interesting. Excuse me, I had to sneeze. So that's fine. Write an extension for the double type that adds an absolute value property. Yeah, that's nice. I think I'll skip that. Sorry. I mean, easy enough to do the double thing, but absolute value property, I'm not sure how I'd write that. So let's continue. You can use a protocol name just like any other type. For example, to create a collection of objects. that have different types but that all conform to a single protocol. You can use a protocol name, just like any other name type, for example, to create a collection of objects. That have different types but that all conform to a single protocol. When you work with these values whose type is a protocol type, methods outside the protocol definition are not available. With values whose type is a protocol type. Okay, so let's get an example. We are going to declare a constant with an example protocol equals a. Print protocol value dot simple description. Where's it pulling this from? Very simple class now, 100%. Oh, it's pulling it from up above, isn't it? Yeah. It's pulling it from up here. Simple class. Example protocol A. Oh. Well, here's A. Here. That's why it's pulling it from up there. Because A is a variable that we declared that's based on a simple class that we called. That's why we're getting that. Protocol value, simple description. Alright. Different types within all when you work with values whose type is a protocol type, methods outside the protocol definition are not available. Okay. Print protocol value, another property. Okay. Now, where did they pull that out of? Well, here's another property. So the question is, why doesn't that work? It worked for simple description. Protocol value. Huh. Has a run type of simple class. The compiler treats it as the given type of example protocol. This means that you can't accidentally access methods or properties that the class implements in addition to its protocol conformance. Here's our example protocol. Example protocol protocols all the way up here. Okay, and that will allow us to do that. A simple class. Rather. Methods or properties that the class implements in addition to its protocol conformance. Okay, I think I understand. Alright, so let's go ahead and do what they're suggesting here. We'll take those comments out and see what the error says. Oh, I think I get it. See, here's the thing. Another property is down here, but that's not part of the protocol, you see. That's why that won't work, I'm guessing. Let's see if that's correct. Alright. Value type of type example protocol. Yeah, exactly. Has no member another property. No, it doesn't. That's correct. It absolutely does not. Yeah, that's right. So at least that part of it I got. So some of this I'm understanding, some not. Even though the variable protocol value has okay, so I get that. You can't access methods or properties that the class implements in addition to its protocol conformance. Yeah, I get that. And now we're into generics. All right. Should we take a quick little break? Sure, why not? But what I'll do is this will still be part of video 6. I'll just add this on to the protocols one. So one moment.